This is a Swiss-made Bell Radio 537 from 1937. And no, that's no coincidence. The radio was made by the Standard Telephone and Radio Company in Zurich, which was a subsidiary of the Bell Telephone Manufacturing Company in Antwerp, Belgium. The radio has 3 frequency bands. It's shortwave, medium wave and long wave. And it also has a setting for PU, which means pickup. You can connect a record player to this radio. On the rear panel there is a little schematic diagram of the position of the tubes, and you can also see it's American tubes because Bell Radio has probably designed this thing. Then we have another connector for an external speaker. We have the pickup connector. You can see there the tone arm. And finally we have connectors for antenna and ground. Ground goes to the water pipe. And here we can see the location of the tubes. 1, 2, 3, 4 and 5. And we also have the tuning capacitors. And also the filters, all the inductors. Everything looks clean and professional. That's because the designer normally built telephone devices. The radio has 4 knobs. Here is the tone control, that's volume control. That's the tuning knob, which has 2 speeds. It has a little gear inside, so you have a fine and a coarse adjust. And finally the selector switch for the radio bands and the pickup. This radio has a quite interesting and luxurious way of telling you what you selected. Here you see this white dot that moves through the band selections and also for the pickup. And how this works is pretty simple but genius. There's a piece of metal with a rectangular window, and you can also see another piece with some white plastic tabs. And when the window is over the tab, you can see it from the front, and if it is blocked, it's black. So that's how this dot is moving. This is the gearbox for the fine and coarse tuning, so the tuning knob is on the top now, and you can see the string that is wound around the bottom part, which then moves the capacitor and also the indicator. As you can see, everything is really massive and heavy, so this is the speaker, and on top of it is the output transformer, and the speaker is mounted with 2 large screws to this beam. In other parts of the world you would build houses with wood of such dimensions. The underside is also really clean for a radio of that time. This is what happens when a telephone company builds radios, so it looks more like a professional device. It also has a detachable power cable, which is pretty unusual for a radio of that age. One of the chassis mounting screws is also a little bit special. It has a hole through it, and this hole is for a lead seal, so you can seal the radio and you see if someone has opened it or not. Capacitors are also a little bit special. They are all made in Switzerland. You can see the condensateur Fribourg from the French-speaking part. This one is 0.1 microfarad. And this one is 85 microfarad. You can also see the crossbow symbol, which designates made in Switzerland. And some of the capacitors are labeled in centimeters. Yes, that was quite common in the days. Centimeters instead of farads. How does that work? Well, when you look closely at the formula for capacitance, you see 2 numbers, epsilon 0 and epsilon r. And then you have the area of the electrode and the distance, which is square centimeters divided by centimeters. The result is, of course, centimeters. But at least the conversion from centimeters to picofarad is pretty simple. You multiply it with 1.1 and you get picofarad. So in this example, the 250,000 centimeter capacitor is a 275,000 picofarad or 275 nanofarad capacitor. But the most interesting part in the entire radio is this device here. And if you know what that is, you know more than I did before. A look into the schematic diagram reveals it. It's a battery. But what does a battery inside that radio? And if it is a battery, how often do you have to replace it, and what does it do? And it's so tiny, what is it good for? A lot of questions, and, well, I finally found the answers. It's a Mallory bias cell. Some tubes need a negative voltage bias on the grid, and the easiest way and also the cheapest way is to use a bias cell like this. It's 18 cents. The other way is a resistor and a capacitor. That costs maybe 30 cents. So this is easy, it is simple, and it works. One important question is, how long does it work and how often do you have to replace these cells? Well, there are reports that some cells are still good after 50 years, so you don't have to replace them anyways. So like capacitors, they age, yes. The idea is, since the cell is only connected to the grid of that vacuum tube and to ground, there is no DC current flowing and the cell basically cannot discharge, so it will hold as long as the chemicals inside are okay. The cell in this radio here has no more voltage. Despite that, the radio still works. But, well, it's almost 90 years old, so I think after that time a battery can go empty. An additional interesting feature is this neon bulb tuning indicator. It works a little bit like those magic eyes you know from the 1950s, but it looks much cooler, right? The only thing that was broken on this radio was the fuse here. This fuse is mounted on the secondary side of the transformer, not on the primary. And it is unusually big, but that also has an advantage. It's so big you can fit a normal fuse inside. That's a 35 millimeter American style fuse with some springs I made. And yeah, that works pretty well. It's the same value of fuse, 300 something milliamps.